My father is a heavy cigarette smoker. He used to smoke 2 packs of cigarettes a day. I was introduced to electronic cigarettes when I was looking for a solution for him to quit smoking. Later, I find that this is not the case. E-cigarettes are harmful to health and even more addictive than regular cigarettes. Using e-cigarettes is also associated with using drugs. Additionally, vapers could have a high risk of cardiovascular problems and even cancer. However, all these facts are not advertised. Instead, information in image like this is advertised. Is vaping cool? Yeah, using Juul is too cool, says the New York Times. This is how the Juul e-cigarettes company marketed itself. Do you know that last year, 500,000 middle school and high school students began vaping e-cigarettes? So, to protect public health, especially our youth, government starts to set the signal. Vaping is uncool. Till now, 9 states regulate sales of e-cigarettes with excise taxes. So what is an excise tax? An excise tax, also called a sin tax, it's a tax imposed before sales price. You may wonder, is this tax effective? Can this tax help us reduce vaping? Well, my research answers these questions. My results show that the tax policy doesn't have a statistically significant change on average sales. And vapers behave differently. Those in the top 5th income range and those in the bottom 5th income range respond to negative signal by reduced vaping. This is good. However, others increase vaping due to a larger decrease of sales price by manufacturers. This means perhaps a 5 cents milliliter is not enough. We need more regulations to set a stronger signal and to reach more people, especially our youth. Lastly, my takeaway message for you is that e-cigarettes are highly addictive and dangerous. I hope all of us and all the kids are away from it, because vaping is as uncool as smoking. So next time, if I ask you this question, is vaping cool? What's your answer? Thank you.
Good afternoon, everyone. Hope you had a great day so far. Did it ever happen to you that you don't get to clean up your kitchen for a few days and everything starts to pile up? Let's see how many of you experienced that. So, like many of you, it happens to me a lot, as you can see from the picture of my dirty kitchen up there. When you're young, healthy, and active, you make a meal, clean up everything, and take out all the waste, and you make it look fresh like a brand new kitchen. As you grow older, or when you get sick, or when you have a 3-minute thesis competition to be prepared for, there is less cooking and cleaning. You just leave all the things on the counter, and you will start to see the waste build up all around the kitchen. Now imagine that kitchen is your body, and the cleaning process is called autophagy. In the other words, autophagy is a process that helps your body to remain clean by removing all the toxins and waste which are produced every day in your body. This process is very complicated and important that the guy who discovered it received a Nobel Prize back in 2016. So in my research, I'm looking at the possible role of this process in a disease called aortic aneurysm. Basically, aortic aneurysm is the weakening of the wall of your body's major blood vessel called aorta. Over the time, the progressive weakening of the wall causes abnormal bulging and expansion that reaches a point that your aorta suddenly tears up and the blood starts coming out into your body. Unfortunately, 80% of the people who suffer from torn aortas will die before getting to the hospital. Since we do not exactly how it happens here, there is no drug to prevent or cure this disease. Now, my recent findings shows that the experimental animals that have disrupted autophagy has a weaker aortic wall, and they tend to have more torn aortas. So what I'm currently doing is trying to better understand how exactly this process is disrupted, and then how this disruption contributes to the weakening of the aortic walls in these animals. So I hope that the result of my research helped to find a dependable drug to return the disrupted autophagy back to its normal condition, to cure this disease, save the lives of many people, and keep that kitchen clean. Thank you.
So like any good granddaughter would do, on Easter Sunday, I met my grandma at church. I said hello, I sat down next to her in the pew, and she turns to me and she says, "So Gabby, how's your chlamydia going?" The ladies behind us, I think, were mortified, but I knew that my grandma was asking about my research. I study the bacteria Chlamydia trachomatis, which is commonly known for the sexually transmitted disease. Chlamydia infects over 100 million people every year worldwide, and these infections are most common in adolescents and young adults. So at some point in your college career, I'm sure that you've met one, if not many, people that were infected. You probably just didn't know it. In fact, they might not have known it either. Up to 70% of these infections are asymptomatic. But even in individuals that show no symptoms, there can be detrimental effects, especially to women and their reproductive health. While the body is trying to fight infection, inflammation can lead to scarring in the reproductive organs, pelvic inflammatory disease, and ultimately leave women infertile. But women aren't alone. Koalas are also experiencing outbreaks in chlamydia and fertility issues. And just because I'm sure some of you are wondering, the species of koalas that infects humans is not the same, the species of chlamydia that infects humans is not the same as the one that infects koalas. However, it is spread the same. And koalas are very promiscuous creatures. In some parts of Australia, up to 90% of the koala population is infected. So despite the prevalence of this infection, there isn't an effective vaccine yet. This is largely due to the fact that we don't fully understand the relationship that chlamydia have with their host. See, chlamydia are obligate intracellular bacteria, which means they must enter a cell in order to survive and replicate. We know that chlamydia have a type 3 secretion system that's a needle-like apparatus, like the one I've shown, that injects proteins, shown by the circle, the diamond, and the triangle, into the host cell. These proteins do a variety of functions, including scavenge nutrients, facilitate entry and exit, and ultimately create a favorable living environment for the chlamydia. This is where my research comes in. I studied 2 of these proteins, and we have created mutant strains in the lab that have these proteins deleted. These strains no longer efficiently invade host cells, and they no longer create as many infectious progeny. My goal is to determine where these proteins are going, what host targets they're interacting with, and ultimately how they facilitate chlamydia entry, so moving from the left panel to the right panel. I hope that my research can elucidate new antibiotic targets and possible vaccine strategies. Thank you.
On October 29th, 1618, Sir Walter Raleigh was led from his cell in the Tower of London into the courtyard for his execution. Upon entering the scaffold, he asked the executioner if he could see the blade. Taking his hand across it, he remarked, "This is a sharp medicine, but it is a physician that will cure all diseases." He forgave the executioner for the gruesome deed about to take place, and then he rounded the scaffold, shaking hands with audience members and asking them to pray for him. He forgave King James for issuing the death warrant and even prayed for James's health and prosperity. Lastly, he recited a psalm, raised his eyes and his hands to God, commended his soul to Jesus, and laid his head upon the block. Sir Raleigh died seemingly without fear or pain. This art of dying well was a performance all of its own in early modern England. And dying well included braveness, calmness, acceptance of one's fate, and most importantly, ultimate submission to the law and to God, as we saw in Raleigh's execution. My research looks at these performances to examine the underlying power structures. More specifically, I review how early modern government and its authorities utilize death to control the living population while punishing the criminal. Public displays of execution work to remind the witnesses of the ultimate power of the law, to let one live or to make one die. These themes are prevalent throughout early modern literature across all of the genres, including sermons, pamphlets, and plays like those of Shakespeare. When we better understand how these themes present themselves in literature, we can better see how those same themes carry over to our current culture. Though the details have changed across time and continents, we still see government-sponsored executions used to exhibit the punishment of the criminal while reminding citizens of the consequences of transgressing the law. For example, on the morning of June 11th, 2001, citizens of Oklahoma City saw live stream footage of Timothy McVeigh's execution. And in the coming years, this tradition will continue as citizens of Boston will witness the execution of Dzhokhar Tsarnaev. Thank you.
On March 23rd, 2011, my aunt had a stroke. And while I'm happy to say today that she is a stroke survivor, that's not to say that the road to recovery wasn't without its trials and tribulations. Her memory was suffered, her speech was impaired, and she had something in her arm known as spasticity, which is like a Charlie horse or a muscle spasm that you can't simply fix by just stretching out the muscle. She was able to overcome her speech impairment and memory impairment through two things: exercises through physical therapy and practical use on a daily basis. However, when it comes to spasticity, only one of those is able to be used effectively, and those are the exercises and physical therapy. Here's why. Say I have spasticity in my hand or in my arm. That's going to cause a contracture in my muscle in my forearm, and that's going to cause my hand to be clenched into a fist. I can't practically use my hand if I can't open it. So physical therapy is the only option. However, physical therapy is a long process. We're talking months, if not years, to recover. And while you're recovering, there are currently no devices that provide immediate function back to this hand. And then thirdly, while there are devices that are meant to be taken home such that the patient can do physical therapy in their own home, they're often made for the average person, not the individual, and that makes these devices uncomfortable and therefore ineffective. Who wants to wear a device that is discomforting? So, my solution to this problem is a 3D printed, customized orthotic glove that helps people like my aunt to have a more convenient and faster recovery. How does it do this? For one, it's meant to be worn such that it opens up that balled up fist, and that allows immediate function of the hand. Secondly, it's made for that individual person, which means that it's comfortable enough to be worn throughout the day. And now that they can use their hand throughout the day, that means that their quality of life will improve and they'll recover at a faster rate. The question is, how does it get made for that individual person? That's quite the task. That's what my research is dedicated for. I'm developing an algorithm that does just that. It starts with the right kind of data, such as hand size, grip strength, among other pieces of data that are immediately available to a therapist through tests that they conduct on a daily basis in their clinic. It gets put into my algorithm that uses concepts from anatomy, biomechanics, and mechanical engineering design to create the right glove. My aunt did not have a device like this during her recovery, but my goal is to have other people in the future that will. And that's how I'm revolutionizing physical therapy. Thank you.
I'd like to begin by telling you a story about Anne. When Anne was just 6 months old, she was diagnosed with pediatric leukemia. After a turbulent 2 years of cytotoxic chemotherapies Anne finally went into remission, but because she had been exposed to such harsh drug treatments at such a young stage of life, Anne had a variety of developmental side effects, such as an inability to walk, delayed speech, and cognitive issues. While Anne's story is ultimately a joyous one of recovery and remission, when we study pediatric leukemia, it's important to not just focus on how to cure the cancer, but also on the quality of life after the cancer. In our lab, we study pediatric leukemia, which is a cancer of the blood in children, using a zebrafish model. Using a model animal in research is a little bit like fishing. You've got to have a hook, a line, and a sinker. The hook in this case is going to be the disease that we're interested in studying. The line is the tool that we're going to use in order to understand that disease. Zebrafish may seem like a surprising choice, but zebrafish DNA is more than 70% similar to human DNA, and we share many of the same genes. A gene is a piece of DNA that is important to create characteristics in an individual. We use zebrafish because they're small, they're easy to handle, they're easy to maintain, and we can engineer them. And so we've engineered these zebrafish to be translucent and to have a fluorescent leukemia so that we can track the progression of the leukemia in development in the fish in real time using fluorescence microscopy. That's our line. And then the sinker is going to be what we use to sink deeper into our understanding of the disease. In this case, we're going to compare the genes in our pediatric leukemia model versus the genes in our healthy zebrafish and see which genes are important to make this leukemia progress faster, and then we're going to target those genes. One of the genes we've discovered that's important for leukemia progression is called PRL3. What we've seen is that when there's high expression of PRL3, leukemia progresses faster, becomes more invasive, and is correlated with a worse prognosis in patients. Additionally, when we inhibit PRL3 with a specific chemical inhibitor, we see that more leukemia cells die than normal healthy cells. And importantly, we've identified several drugs that are already on the market to treat other diseases that can target PRL3. However, these drugs have less side effects than traditional chemotherapy. And when we use these drugs on our pediatric leukemia fish, we see a decrease in leukemia burden. These results are important for two reasons. One, it demonstrates that we can use our model to identify novel genes. And two, that when we target those genes, we can reduce leukemia burden. This is called a targeted therapy. And the hope is that with these targeted therapies, we can reduce side effects, increase quality of life, especially in vulnerable patients for people like Anne. Thank you.
Of pet keepers in this room, I imagine a good number of you consider pets a member of your family. This is the reason why phrases like cat daddy, fur baby, and pet parent abound in our culture. However, we might not expect that people around 200 years ago thought of pets as similarly important. Yet pets are important in Thomas Rawlinson's Cat-Like Courtship, in which a man tries to force a kiss on a distressed lady, while 3 cats come to her defense, clawing their way up the man's back and biting his derriere. This picture gets at the focus of my research, the role that 19th century pets play in the home and in stories. In the home, who, human or animal, is considered a member of the family, and in stories, who is an important character. Pets then and now offer an alternative from traditional gender, marriage, and family expectations. Rawlinson's picture dramatizes the forces that would strip a woman of her power of choice, while pets fight for her to maintain her independence. In Charlotte Bronte's 1849 novel Shirley, the character Shirley meets and is attracted to a poor tutor. Her family wants her to marry a rich man, but she marries the poor man who she actually likes. The story's a familiar one. What is less familiar is the role that pets play, particularly Shirley's dog Tartar, in moving the story forward. Much like the angry pets on the slide behind me, Tartar chases an unworthy man off of Shirley's property. At the same time, Tartar shows physical affection for Shirley's eventual husband, even while Shirley herself holds him at a distance. A 2016 Washington Post article shows how pets continue, like Tartar and Shirley, to offer alternative family structures. According to this article, millennials are 50% less likely to be married or live with a partner than were their predecessors 50 years ago. But they're more likely to live with pets. So with pets at their side, millennials are taking their lives in different directions personally and professionally than the generations that came before them. Much the same, 19th century pets allow people, especially women, the power to make decisions about their own futures. Whether it's a dog like Tartar giving or withholding his blessing for a marriage, or my two cats offering me companionship as I build my career, pets provide different options for what our lives can look like. Thank you.
What is the price of a human life? According to economic research, the value of 1 year of your life is $200,000. This is calculated based on what people are generally willing to pay to live 1 year longer. My title comes from the cartoon shown on my slide, where the philosopher asks, if you were in a burning building, which would you save, an elderly woman or the Mona Lisa? And the Economist answers, easy! The Mona Lisa is worth 872 times the value of a human life. This is why other disciplines call us the dismal science. But joking aside, economists have a good reason to try to place a monetary value on life. Death is the most important and obvious health outcome. I mean, take a pulse. But the value of saving a life is $0 to the government, unless economists assign a number to the benefits of life-saving programs. My research assesses whether the money Medicare spends on prescription drugs saves lives. The government helps seniors with rising costs of badly needed pills such as heart medication. Now, those of you under the age of 65 may be wondering why you care. Well, besides the fact that all of you will eventually become seniors, like it or not, you're the ones footing the tax bill. I'm here to talk about whether you're getting the bang for your buck. Although I don't find any impact on the white population, minorities have significant positive gains in lifespan, with the greatest for African American men, who experience a 9 percentage point increase in their probability of living to age 73. Adding up the value of each extra year lived per person, I estimate the benefits of Medicare's drugs to be $118 billion. That suggests the program isn't effective because the price of the last decade was $499 billion. But if we only looked at spending on African American men, it would be cost effective. So the lesson here is that we need to focus more on the poorest population. I want my research to improve government policy, so I have a suggestion. Simplify the sign-up process, please. There are hundreds of plans, and they change every year, which is why patients joke that 99% of Medicare drug plans give the rest a bad name. But in conclusion, I don't want to deny the benefits of Medicare. I estimate 66,000 lives saved, and that's surely worth something. Worth $118 billion if you're a dismal scientist like me.
In 2016, a young rider named Olivia Inglis and her horse Coriolanus galloped out of the start box to go compete on cross country. Now the course was fabulous. They were galloping up and down hills, in and out of water, jumping giant jumps like picnic tables and fallen logs. But then the worst happened. Somehow, while jumping, Coriolanus hit the jump on the upper part of his front leg, causing him to somersault over the fence, much like the horse in this photo. Now, Coriolanus landed on his back, fracturing it, and he also landed on Olivia, crushing her. Coriolanus had to be euthanized, and Olivia passed away. This super dangerous type of somersault fall is called a rotational fall. Now, there's only about 36 of these rotational falls per year, while there are over 700,000 jumps attempted in international competition. But when they do happen, the results are often devastating. Now, these jumps could be avoided if the jumps would just magically disappear, if the horse is going to hit them and rotate, or if the jumps fell down with just a light tap. But horses like this horse, jumping these fences, they'll scrabble across it, brush through all day with no consequences. And riders fear that if the jumps would just fall down, then the horses wouldn't be careful, and then it would make it even more dangerous. So the solution to this problem is that we need to create a fence that falls down only in the situation that a rotational fall would occur. So how would they occur? My research seeks to find that perfect storm of conditions that cause rotational falls. Now, obviously, we would never want one of these falls to actually happen to a real horse and rider, so we created a physics model. We created a Monte Carlo type model which is performed over distributions so you can predict outcomes with different incoming situations. These models are used by NASA to land on the moon. It's used in economics. It's widely used for weather predictions on the news that you see every day. My model helps predict different speeds and different jumping positions for the horses and riders, as well as different sizes for small or large horses coming on course, men and women who compete evenly in this competition. So the results of my study are that the jump should fall down with a hit or an impulse in mechanical engineering of 500 to 1,000 Newton seconds, and it should be tailored within a specific angle range based on the elevation where the horse is going on the course. Putting a jump with these specifications on course could reduce the amount of rotational falls per year from that originally 36 to only 19. That way, horses like Koalas and riders like Olivia can keep competing in the sport that they love without consequences if someone like you or me can design a jump to meet those specific specifications. Thank you.